This is IREX, a reusable process for the iterative refinement and explanation of classification models. We offer IREX, a new and reusable explanation method. It not only focuses on the explanation but also improves any classification model. This method is designed to automatically identify anomalous variables in a dataset by following a cycle analogous to case-based reasoning. It also applies a smart combination of other available explanation methods, such as ale, lime, SHAP, and feature importance. IREX offers a novel visualization approach using heat maps, allowing to appreciate the detected anomalous variables. And of course, it's a completely reusable, ready-to-use implementation. IREX is aimed towards the domain expert without artificial intelligence skills who may need to improve a classification model. The expert will be able to identify which input variables led to the anomalous classification, while understanding its impact and refining the model. Now, our strategy is to follow a cycle analogous to CBR, represented by the picture in the center, where a list of potentially anomalous variables that may lead to misclassifications are: first, identified using ale, then are proposed for its revision, where the domain expert evaluates those variables. Next, the conflict variables will be removed from the input dataset, and the model will be retrained and reevaluated in a following cycle. And this with the purpose of improving the classification model. IREX only requires the expected classification outcomes given by a domain expert. Now, let's talk about the first step of the cycle, the identification of potentially anomalous variables. IREX uses ale for this purpose. As we can see in the picture on the left, ale generates a different kind of slope, one for each class. How does this work? Well, in this case, we're classifying the variable 1 in class red or green. For IREX, if the slope tends to rise, it contributes positively to be classified as that class. But if the slope tends to go down, it contributes negatively to be classified as that class. For the input variable 1, if we focus on the slopes on the left, we can see that for the red class, the value b contributes positively to be classified as red, but to the value a contributes negatively to be classified as red. That's because of the slope that tends to rise on the value b, but tends to go down on the value a. It's the same for the green class. The value b contributes negatively to be classified as green, but the value a contributes positively to be classified as green. Once we understand this concept, we can compare ale values to the expected answers given by the domain expert to identify potentially anomalous variables. Here we have an example of a non-anomalous variable. In this case, we have 3 classes instead of 2, like in the last picture. For this variable, the domain expert expects that the value that equals 1 contributes negatively to classify the instance as class 1, but positively to classify the instance as class 2 or 3. This variable is non-anomalous because it follows the expected answer. As we can see, the blue slope, class 1, tends to go down, and the orange and green slope, class 2 and 3, tends to rise. Now we have an example of potentially anomalous variables. Just like before, we have 3 classes. For this variable, the domain expert expects that the value that equals 1 contributes negatively to classify the instance as class 2. But in the picture on the right, we can see that the class 2 slope, the orange one, tends to rise. This variable is potentially anomalous because it does not follow the expected answer. Now, here we have the past images side by side so we can compare them. This is an example when applied to the provided dataset. The input variables are questions and the classes are low, medium, and high.
IREX allows the use of heat maps in non-common domains, using them to explain input variables in the model. Using 2 color scales, the blue one to represent known anomalous variables, and the red one to represent possible anomalous variables. The stronger the color means the more relevant the input variable is to the model. IREX uses multiple explainable artificial intelligence techniques, or SAI for short, such as feature importance, lime, shape, and ale to create heat maps, allowing the expert to easily identify the anomalous variables, as well as giving a wider picture of the relevant variables, anomalous and non-anomalous. The iterative process ends once IREX doesn't detect any possible anomalous input variables. However, IREX automatically generates graphs comparing the number of identified anomalous input variables and the refinement of the model throughout each iteration. IREX uses a smart combination of multiple side techniques to refine and explain models. The method uses an analogous cycle case-based reasoning being made of three fundamental stages. Retrieval, a stage where potentially anomalous variables are identified. Revision uses side techniques to revise the previously identified variables. And retain, finally, where the model is refined and retrained after removing the anomalous variables. A novel visualization approach using heat maps to help the explanation and refinement of the model can be applied in heterogeneous domains where their use isn't common, and a great simple visualization for domain experts without machine learning skills, and makes an automatic, easy to understand comparison between the model's performance and the number of anomalous variables for the domain experts. IREX can be used with any classification model and domain, and is easy to adapt and modify. Only requires the model dataset and expected variable outcomes from the domain expert, and is ready to use at GitHub and Google Colab. The method is allocated at GitHub in case anyone wishes to access it. Google Colab has IREX ready to use and fully customizable. We also have a PDF of IREX Jupyter Notebook with mental health model loaded in, and a video where we show IREX running and the results we obtained throughout it. This concludes our presentation. Thank you kindly for your attention. We are IREX team.